Bueno, bienvenidos a todos. Gracias nuevamente por venir, a todos los que están presentes y todos los que nos están viendo tanto desde Zoom como desde YouTube. En el día de hoy vamos a tener el último coloquio de este primer cuatrimestre del año. Para cerrar, tenemos a dos oradores el día de hoy, a la doctora Celeste Saulo y al doctor Takemasa Miyoshi. La doctora Saulo es directora del Servicio Meteorológico Nacional. El doctor Miyoshi recibió su título de bachiller en física teórica en la Universidad de Tokio y realizó su máster y doctorado en asimilación de datos por ensambles en la Universidad de Maryland. Desde 2012 lidera el equipo de investigaciones de asimilación de datos en el Centro Riken de Ciencia Computacional. Fue además galardonado con numerosos premios y junto con la doctora Saulo son investigadores principales del proyecto PREVENIR, del que nos van a hablar el día de hoy. Muchas gracias a ambos. Las presentaciones van a ser en inglés y les pedimos que también las preguntas las dirijan de esa manera.
Gracias, Natalia. Thank you very much. Good day to everyone. And it's my pleasure to share with you the presentation of this project. Can you hear well? Yes? Okay, thank you very much. So the name of this project, as you all know, is PREVENIR. Thank you for allowing us to use this acronym that sounds very well in Spanish, not so good in Japanese or English, but it stands for forecasting and early warning systems to deal with flash floods events. So I prepared this with the aid of Shanina and Juan. Thank you very much to both of you for doing this. So first of all, it's important to share with you who are being part of this project. And you can see here, I don't know if there is the red one? No. Okay, the red one. Thank you. So in the middle, you have the SATREPS, which is the name of the program that is funded by JICA and JST, which are both institutions from Japan that are supporting us. And in the top, we have the Argentinian participants, and in the bottom, we have the Japanese participants. And as it was said by Natalia, Takemasa Miyoshi is the principal investigator for this project from the Japanese side, and I am the principal investigator for the Argentinian side. But what is nice to see from this picture is the large degree of institutions that are involved in this project, because this means in some way that we are dealing with a complex system and we are facing a complex kind of collaboration, and this is being done from the very beginning, and this is what we want to highlight. So what is PREVENIR? It is written here. We will work on an early warning system that will be developed, including efficient communication tools such as cell phone apps and web portal. The system will be optimized and tested over 2 highly populated basins, which are these 2 basins that are here in this map. The one to the right is the one corresponding to Sarandí and Santo Domingo in Buenos Aires, and the one to the left is the Suquía River Basin in Córdoba province. It's also very important to highlight that these 2 basins also present different challenges in terms of monitoring, hydrometeorological modeling, and also social vulnerability. So that's why we have selected these 2 main basins. Just to have a zoom like approach to these basins, here is the Suquía River. Here in dark, you see Córdoba City, and of course, the basin affects a very large portion. Here you can see most of that portion, and of course, there are lots of population, there are lots of people living in these areas, and these are clearly pictures that show the impact of heavy floods and heavy precipitation events over these regions. Something similar happens to the area in Sarandí, Santo Domingo River Basin. Here you can see the area of this basin that affects several areas of Buenos Aires province, Avellaneda, Lanús, Lomas de Zamora, Almirante Brown, Florencio Varela, and Quilmes. And again, you can see that as a consequence of heavy rains, we have this kind of impacts and I would say disasters over the area that is again very vulnerable. But of course, Takemasa will go into the details of this project on what we are planning to do with this project and how we are planning to collaborate with this project among us. But I would like to highlight also why we could get or we could arrive at this stage of collaboration between institutions and between colleagues from Japan. And this is what I will show you in the next slides. First of all, our Met Service has a strategic plan for 2020-2023 with several priorities, but one of those priorities is the reduction of societal consequences of high impact weather events and the improvement of emergency management decision-making by sharing meteorological information timely and effectively. So this is a core aspect in our strategic plan, and that's why PREVENIR is so important for us, because it goes straight into what we want to do or we want to achieve in this time frame. We also are interested in increasing the added value of meteorological information for the benefit, of course, of productivity and social well-being. So this is PREVENIR is part of our strategic plan. PREVENIR is also possible because we've been working for a while to improve our capacity in terms of supercomputing and our capacity of running complex and heavy models. And thanks to this project that we shared with CIMA, UBA, and SMN, we were supported by our Ministry of Science and Technology, and we could buy I would say the largest supercomputing system that is devoted for operational activities like the weather service, for example, in all Latin America. So this makes a big difference for us as a weather service with respect to other weather services in our region. And so this allowed us to not only to try several different kind of approaches for ensemble forecasting and data simulation and many other strategies, but now we have a robust system of high resolution running to cover all of South America, Argentina and surrounding areas. Another thing that helped us or prepared us to really take advantage of PREVENIR is that we've been working in a new early warning system at our Met Service, and now our early warning system looks like this, completely different from how it looked before, and there were many people involved in this new kind of system. And when I say many people, I mean actually many people from science, natural sciences, exact sciences, social sciences, and end users like for example, civil defense or this is what we say, that we have been co-producing this early warning system that deals with rains, winds, storm, heavy snow, and sonda winds. So we have a background to work with in collaboration with the final users or the decision makers that need this information to react. Another important thing is it has to do with, let's say, intergovernmental kind of arrangements that make possible that when you make a new system, you have a new system, they will they will use that system, because if not, you are only part of this very complex wheel, and you need other players on board. In this case, the security ministry is the one that is responsible for civil protection, essentially, and they deal with each state within Argentina to really be effective in terms of emergency management. So again, this agency in particular, SINAGIR, is a kind of collaboration between many ministries in the government, at the governmental, national governmental level, that helps us to really coordinate between the weather service and other actors that are very critical to really get into the field and work with people when there is an emergency. The other important aspect has to do with infrastructure, and the radar infrastructure has improved a lot in Argentina thanks to our public work ministry that has essentially funded the acquisition of these radars. You can see we have now 15 operational radars in Argentina. That is a significant amount of radars, and particularly to highlight is that we receive the information from all these operational radars in our Met service, and that is another asset, I would say, because maybe other countries have many radars, maybe much more, but there is not something like a network of radars as we have thanks to SINARAME, which is the name for National System of Weather Radars. So this is something that gives us background to get this extra information to improve the let's say the description of the current state of the atmosphere, nowcasting, and then forecasting or using complex models. And at the regional scale, we've been also, as I'm trying to put some emphasis in all the, I would say, the legs that we need to really take advantage of PREVENIR. I started mentioning initiatives at the Weather Service, and then I mentioned initiatives that have to do with coordination among institutions, and then coordination among ministries, and then coordination within our region in South America. And this is thanks to a program of the WMO that helps or tries to build on the trying to make a better data exchange at the level of hydrology. We are very good at sharing data at the level of meteorology, but not so good at the level of hydrology. And this is something we want to improve. And we are working with INA strongly at the level of La Plata Basin, which is one of the main basins affecting the southern portion of our continent. So we are very happy that this is happening. This is more or less the backstage, for me, the backstage of why we can build now, and we can be sure that PREVENIR will give a lot to both of us, to our Japanese counterpart, as well as Argentinian scientists and decision makers. But we are changing a paradigm here, sorry. And I would like to highlight this change of paradigm from my perspective that has to do with the approach of PREVENIR. PREVENIR is not working like this. What does it mean? This it's like we have the scientists here, we have walls between different disciplines that says, let's say this is hydrologist, this is a meteorologist. They are preparing their papers, and then the paper flows. We don't know how, who can understand, what can they do with that information. And then the society is waiting for something, but perhaps they can pick up the paper, but I don't know what can they do with that paper, actually. So PREVENIR is changing this thick dividing wall and moving into something like this. Thanks, Lucho, for your pictures. And we can see, but Takemasa is dressed in yellow as he is today. So he looks brilliant, and everyone can see Takemasa. But besides Takemasa, you can see here Mariano, you can see people from the civil protection, you can see territorial actors, you can see Juan here, you can see school, the Project Mateo, you can see Shanina, you can see this anemometer in the top of the school. So this is the kind of change of paradigm that we want to work. We would like you all to work for this change of paradigm. It's not science will not achieve what it's meant to achieve unless we try to cross those barriers between the academy and the people. So thank you for helping us to change this paradigm. Also, I had this is a picture. Sorry, this is a schematic, but it was full of pictures that I took also from Lucho's, but the PowerPoint became crazy and I lost everything. But I had a picture of one of you along all these value chain. And I would like to highlight this context and this also conceptual framework for science for services, because we want to work in this paradigm of science for services. And I will go through this. This is I don't know if you can recognize, but this is squid, calamar, I would say in Spanish, squid. And then you can see that starting from observational infrastructures and boundary conditions and observation and monitoring, and then our system data simulation, ensemble prediction, big data sciences, HPC, artificial intelligence, and so on. You have all of this in the, let's say, scientific kind of area, and then you need specialized users that can digest in some way this and try to post-process, do human interface, verify, and then really reach all users. Let's say end users like a politician, a decision maker, and an emergency manager. And then all these needs, again, a co-design partnership resources to a network projects like this one that possibly will bring new technological frontiers. And then this is like a cycle. So to finish, I would like to express my sincere appreciation for having PREVENIR as a change of paradigm, as a challenging kind of project where you are all invited to be part of from whatever part you feel more comfortable with. No? So thank you very much. And now it's a turn for Takemasa. Thank you.
Take questions? Maybe at the end. Okay, thank you very much, and thank you, Celeste, for the wonderful talk. And now I feel very difficult because after the great talk, maybe my talk will not be as good as yours. Well, but anyway, I will do my best to introduce what we plan to do in this PREVENIR project. So this is a project for numerical weather prediction and warning communication system. for densely populated and vulnerable cities. So I'm the PI of the Japanese side, as Celeste already introduced, and Celeste is the PI of the Argentinian side. So my main affiliation is RIKEN. RIKEN is scientific institution in Japan. So we study all fields of science, including even social science recently. So we are not limited, but this is a science institution. So the goal of RIKEN, or mission of RIKEN, is to do the top science in the world. So we try to be some best in the world in a very specific area. So we cannot do everything the best, but we have scientists in RIKEN, and every PI of RIKEN should be top in the field. So I hope that I'm representing data assimilation field. That's a very narrow field if you think about the whole science areas, but I try to be the top of the data assimilation. So we have this supercomputer called Fugaku. Fugaku is a second, an alternative name of Mount Fuji. Mount Fuji is the highest mountain in Japan. So it has a wide area, but it's a single isolated mountain. So this is, you might see this logo of Fugaku showing the highest peak performance, supporting a lot of applications. That's the concept. So this is a general machine, so that it's not specialized to some specific applications, but it can run many different types of applications with a good performance. So we take advantage of this supercomputer that until recently, this was ranked #1 in the world. But recently, they updated the list. And there is another one, the one in the US reached more than exaflops. This is like 400, maybe you could take a look, but 400 petaflops. And this was the #1 computer. So we do the top science in RIKEN, and the idea of PREVENIR is to combine the top science and the society, as Celeste already introduced. So we do the top science, but the science should be part of the society. So we work with the society, and the science can be useful to solve some social problems. So this particular project, SATREPS, this is a scientific project, but at the same time, this is a partnership with Argentina in our project. And SATREPS is a program that supports many other countries as well. So there are many projects partnering with other countries. But in this project, PREVENIR is particularly partnering with Argentina. This is bilateral, so it's only Japan and Argentina in this project. And Celeste represents the National Meteorological Service of Argentina. This is not a science institution, but this is operational weather service. So this is more connected to the society directly. But RIKEN is a science institution. So this is really well designed in that sense, so that we do the top science. We have a partnership and apply the top science to the society in Argentina for the global problem solving. So the global change, or the climate change, is a global issue, so that we tend to have more extreme cases of the weather events. So we have more severe flooding or other types of extreme weather affecting the society. That's why it's not only in Argentina. Japan also has similar problems, and other places in the world as well. So we focus on very specific areas, local regions in Argentina, only 2 specific areas in Argentina in this project, but we aim to to solve more than that. So this is just a typical examples what is going on in the world, but these two regions kind of representative of those problems. So that's our concept. So this is already introduced by Celeste, so I will skip. And this shows the whole structure of the project. So to solve the problem is the weather affecting the society. So the society needs to respond to those weather. So one thing that we could do is to build a strong infrastructure so that the society will be more basically stronger to those extreme events. But that costs a lot, and also it's not easy to do that. So another way of tackling the problem is to have a good prediction and prepare in advance. So if you know that we have flooding, then in 20 or 12 hours later, if you know that in advance, then we can take some actions to prevent ourselves. Prevenir is like prevent, is that right? Yeah, it sounds like prevent. So I could guess. Well, so that's the idea. So that's why we have this bottom half component of this research. We think that it's important to communicate what we get from these science methods, technologies, but this information is for the experts. It's not easy to understand for general public. So we need to communicate this expert knowledge to the public in a good way so that they can prepare in advance. So we will develop this communication system, the early warning communication system. And also we will work with the communities so that the people can understand what is communicated. The communication is not one way, so we need to do the two-way communication. So this is very important. And this is the technological development part. So we will use the top science knowledge here. So first we observe. So that's the top left part, the work package one. So we observe through what we can. So we cannot observe everything. We cannot put sensors everywhere in the sky. It's impossible. So we take the data from satellites, existing satellites. We will not launch new satellites for this project. So we use just the existing satellite, and we have existing radar network. So we will take advantage of that. But processing the radar data is not trivial. In the Japanese Weather Service, they have some knowledge, and also our research team has advanced knowledge on processing the radar data, particularly removing the noise or those processing. So we apply those to improve this sensoring technology. And this sensor data is now then going to this prediction system. So this is hydrometeorological forecasting system here. So we have first estimates the precipitation amount based on what we get from the data. So it's not trivial, again, because the radar, for example, observes the reflecting return power. So they emit the radio wave, and if there's raindrops in the sky, then those raindrops will reflect the radio wave back, so that we observe the reflecting power. Then that will give us some idea about how much rain there, but it doesn't necessarily mean that that's the intensity of the rain that we feel on the ground. So this is really a difficult problem. We will work on this, the quantitative precipitation estimation. That's also called QPE. And then we apply a relatively simple method, but it's for prediction. So we have rain patterns moving in time, then we can track the motion. That's the basic technology for nowcasting, what we call nowcasting, because we can predict only in the limited time. So we have the real-time monitoring of the rain, and then we just extrapolate in time so that we can get the prediction of the rain maybe in the next a few hours or maybe up to 5 or 6 hours. That's the limit to predictability based on this nowcasting method. So we have another approach for the longer range prediction that's based on the numerical weather prediction. To do the numerical weather prediction, we need to take the data into this prediction system. So we have a model of the atmosphere that's physically based, so that we solve the equations based on our physical understanding of the atmosphere. But it's separate from what's actually going on in the actual atmosphere. So we take the data, but the data is imperfect. So we always have noise, or we have missing data. We cannot observe everything. So we need to have a very advanced method to incorporate that data from the real world to the computer model. So this is called data assimilation, and we call it big data assimilation because we deal with the big data. So this is something that we developed in Japan, and I hope that we can include those advanced technologies here. So this can give us even longer range prediction of the precipitation. Then we will apply the hydrological modeling. The hydrological modeling is based on the idea of the water flow. So if you have a slope, then the water will flow along the slope. So that's a basic idea. So if you have mountains and if you have rainfall on the mountains, then it's naturally the water moves along the slope. Then it forms a river, so we can compute the river flows. And if the river flows increase rapidly, then that will be the risk for the flooding. So this is a hydrological model. Then these outputs are, again, very complex. So we have expert forecasters, a prediction system, and we will develop the communication system. So that's the whole structure of this project. And to do this, we will buy some equipment. So we need computers. So we will buy computers in the weather service and for research as well. Like here, CMI should be here, right? In this building, I guess. Yeah. So we will have these research computers as well. And also we will enhance these weather stations and also the hydrological monitoring, like this camera or drones and the water level sensors. So these are the things that we will get for this project for the improved prediction. It's already shown, but this shows the Japanese letter, so it may appear differently to you, but it says Argentina here, and this is Cordoba and Buenos Aires. These are the two locations, and I have some pictures. So this is the area of Buenos Aires, and we identified this area really vulnerable. And we had a visit last week to these areas, and we saw that this river is really a problem when we have some rains in the upstream. So this flood, and it happens quite frequently. So we would like to develop a focus on this region in this project. And this is the region, a small area with a population about 5,000 people in Cordoba. So this area is also a lowland, and this river, Suquía River, causes flooding in this area. So this is also a very vulnerable area. And again, last week we visited this area and talked to those local communities, and we found that this type of research is really important in that area. And this is a bigger picture. So this is the area that I showed with 5,000 population, but this Sukia River collects all the water, the rainfalls in these regions. We have a dam here, but this dam, because this is semi-arid area in the winter, so they have to keep the water here. So it's really difficult to use this dam to prepare for the heavy rain, because they would like to keep the water level high. That's what I heard. And if they release the water, and if the prediction was not correct, and if we didn't get the water, then they will be that will be a problem of water resource. So this is a complex problem. This is not just about the flooding, but this dam is important for the water resource. So the society is complex, and there are many factors that we need to consider. So this is a difficult problem, but that's why the science can help on those cases. Okay, so just to highlight what will be the value of this project, this shows the current situation. So the weather service has the prediction system. That's great by using this high performance computer that Celeste mentioned. This is the most powerful high performance computer for the operational weather prediction in the whole South America or Latin America. And that can make this very precise regional numerical weather prediction. But the problem is that although the weather service already has a very good radar network, these data are not used in here. So there's a gap between the observations and the prediction system. So that's the main reason why the warning information is vague. It's not very precise, so that people don't know how to react to this warning information. It just say that heavy rain possible in your area, but how possible, not sure. So if you evacuate, for example, but you are not sure if the evacuation is the right action that you take. So that's why people get confused like this. So the idea of this project is to integrate all this monitoring system and the prediction system and the hydrological prediction system as well. So we integrate all of these components here so that we have the integrated big data simulation, nowcasting, numerical weather prediction, and hydrological modeling from the monitoring system. So this can produce, ideally, a very precise prediction information, like this warning, urban flood possible in your house. This may be too optimistic, but this is a goal that we aim. So if you know that your house will be flooded in the next 12 hours, then you should do something. You should protect yourself. So they know how to do it because they experience like once or twice a year the flooding. So they can prepare in advance so that minimize the impact from these events. We cannot change the nature, but we can change our activities. So we can change our actions. So this system will have that social impact. So this is my last slide showing very nice pictures from the past, my past visits to Buenos Aires in general. So this is 2015, but my first time in Buenos Aires was 2008, around this time, like October, November period, when there was WMO hosted meeting on data assimilation, basically. It's a 4D VAR and ENKF intercomparison meeting. so hosted by Celeste that time. And so we had a summer school here. There was no this very nice new building at that time. So we had lectures in Pavilion Uno, Aula Magna. So I still remember. So every day we had lunch, the same place, cafeteria, Pavilion Uno. So I really enjoyed the Porsche this time as well. They didn't change the menu. That's what I realized. Well, so it's really a partnership and friendship. So everything started from then. So my advisor is Professor Eugenia Carney, and she's an Argentinian, and she is now in the University of Maryland. And so I worked with her quite a long time since I joined the University of Maryland as a student in 2003, I think 2003, yeah. And I got a PhD in 2005, so that was very quick 2 years. But even after that, we had really continuous relationship, friendship, and so she gave me a lot of I don't know, not explicitly, but Eugenia gave me a lot of impressions about Argentina. So I didn't feel like that Argentina is other country. So it's part of my I don't know how to describe, but it's like my family's country or something. So I really am happy to be here again and to have this kickoff meeting in person, particularly under this very uncertain and chaotic world conditions. I could still travel all the way to here. That's exactly the other side of the earth. And this opportunity, I'm really grateful, and thank you very much for this opportunity.
We have now time for questions. Please raise your hand and I will pass the mic. Any questions here or in the Zoom? I have some question for both of you. I don't know much about the project. I just hear from you. But I would like to know if you have an expected time to have the first results of it.
Okay, so this project, sorry, I didn't mention about it, but this project lasts for 5 years from now. So it's a 5-year term project, and we have basically every year we will have something as an outcome from this project. So we have a very well structured timeline. It's really Japanese in that sense, but this is a half Japanese project. So we will, have those. For example, we will have some monitoring system starting as soon as possible, so that maybe by the time next year, within a year period, we will have new observation instruments installed in those areas I showed. Yeah, thank you.
How much time do you think the research part of the project will take and the communication will take?
That's a very good question. So we spend the whole 5 years to both of them, actually. So the communication and the education takes time. So we will discuss what will be the effective way to communicate with the local communities. And so we will have some sessions, study sessions of those. And the Argentinian scientists already started doing those activities. So, and also in the past already some relationship with the local community has been built. So we try to expand those activities, and that takes time. So the 5 years may not be enough, but the 5 years will be very useful to accelerate those activities and even expanding to other areas as well. And for the scientific part, it's also similar. We have something already built, like the numerical weather prediction system, although the radar data are not used in the operations yet, but still the weather service and the university here has some research activities try to incorporate the radar data with the numerical weather prediction. We have our Japanese efforts as well. So this project will combine those knowledge and to develop something more advanced and new and useful. So these 5 years will be very useful, but it's not the end. So we need to continue the development in the future. So we will try to build the basis for that in these 5 years.
This is more a comment and less of a question, but of course, this is as I've been showing, this is a cycle between scientific research and operational activities and services to the public. It takes your whole life, I would say. It's more than a life there. Something I would like to highlight that I learned and not long ago, and here we have colleagues that SATREPS as a program and JICA also. Then after a while, they come back to the country and they assess the level of impact of a project. Let's say 2, 3, or 4 years after the project has finished, and we know that. But so I think this is a very interesting way of also these funding agencies, these international cooperation agencies, to learn how to improve these kind of projects and how to keep the rhythm of the advances related with the project. So I think this is another way of let's say trying to build on what we are going to do here, what will be straight moved into the operational system, and what will start again as a new research project, and I hope it will take a long time.
Yeah, if I can add a few words on top of that. So I said that I have a very good, well, I had Eugenia as my advisor, and I built a very good relationship and friendship with Juan and Celeste and other people in Argentina. But I hope that this project really, well, we have young scientists from Japan and also Argentina. So we build up the new relationship continuous in the future. So it's multi-generation relationship.
Sorry, another funny question, I think. Do you know how many people is involved in this project?
It's quite many. I have a full list of the research members. I don't remember all. Yeah, it's like 100 people or something like that. 100 maybe, or more maybe, because there's Japanese side and not.
Maybe in that list are only the researchers,
Yeah,
or the students, but are not
That's right.
include the people on the field, like emergency managers.
That's true. Yeah,
Yeah.
so we are expanding.
And the kids in the school.
Yeah, that's right.
You have many
That's right.
scientists
Yeah,
there.
yeah. Oh, that's right. Yeah, they observe.
Any other question or comment in the Zoom? Or Julia, maybe you can tell me if there is any question in YouTube. I don't think so. if there are no more questions, I want to thank very much Celeste and Takemasa. It was a great talk. Thank you everyone for coming here and online, the online version of our Coloquios. As I said before, this is the last talk before our break. So thank you for this period, and we see you again in August. Thank you very much.